Hi everyone, Chris Kuzmal here. What we're going to do now is we're going to go through one of the proofs that is in the logic text and just talk about it in order to help with comprehension. So we're going to assume that we have object constant A and a function constant S, and that's written down in English up here, and it's also represented in this bar on the around logic proof editor. And we're going to be given R of A, which is this first thing here. We're being given for all x, P of x implies R of S of x, which is this guy, number 2. Line 3 is going to be for all x, Q of x implies R of S of x. And line number 4 is for all x, R of x implies P of x or Q of x. And our job is to prove for all x, R of x. So show R of x from these premises. And so we have sort of a base case, this R of A here. So we know what we want is to sort of show for all x, R of x implies R of S of x. And we kind of have that. We have R of S of x is entailed by things, but these things are not for all x. These are P and Q of x. But we can see that we're going to be able to get P and Q from line 4. So the first thing that we're going to do is we're going to assume something, which I'm forgetting what it is. So close your eyes. Let me take a quick look at the answer. We're going to assume R of A, okay? And I'm going to try and go back to not the answer. Oh, it's all right. We're going to assume R of A. I'm now really confused because I thought we already, let's take a look at this answer again. We're going to assume R of X. I knew that, but you know, when you're on video, what can you do sometimes? So once again, we go back and we're going to do this. And the important thing here is that we're seeing the mechanics of doing it. I hope that in principle, the concept will be clear once you see us go through the mechanics. So if we assume R of X, then the good news is that we can now introduce each one of these premises into the assumption having removed the universal quantifier, okay? And so X is the universal quantifier here in this scary bit here. We just put in an X, and we get P of X implies R of S of X. And similarly, we do universal elimination on line 3 and line 4. We do universal elimination on as well. So we're getting rid of that pesky universal quantifier that makes it so that while it says it's always true for all these things, but doesn't let us manipulate it. But now we're in a great place here because with R of X and with R of X implies P of X or Q of X, we can immediately do implication elimination and get P of X or Q of X. But if we have P of X or Q of X, and we have P of X implies a thing and Q of X implies the same thing, we can do OR elimination and get the thing, which in this case is R of S of X. Well, this is fantastic because now we have a assumption and a conclusion from it, and we can do implication introduction. Where is it? Right here. To get R of X implies R of S of X. Now all we need to do is a universal quantifier introduction to make this apply to for all X. And badoom bading, line 12 and I think it's line 1 are the two conditions required for induction. So we can just hit induction, and the conclusion we wanted to make was our goal here for all X, R of X. So all we have to do is copy that, paste that into our goal, and it will in fact see that it matches and tell us that we've completed the problem successfully.